Alright, in this video I'm going to be working Algebra 2 Homework 5.3. We're just going to be doing lots of different types of factoring. Sum of cubes, difference of squares, group and factor. There's others I'm not even thinking of. We'll just get started. This first one looks like y to the 3 plus 64. This is going to be a sum of two cubes, right? Because of the y to the 3. And I just got to think to myself, what number cubed is 64? I think it's going to be, it's going to be 4 to the 3. And with the sum of cubes pattern, let me copy that in. Alright, so for a sum of cubes, for sum and difference, it's always kind of the same skeleton, a, b, a squared, ab, and b squared. And it's same sign, so plus, opposite sign, always positive. Okay. So if I've got y to the 3 plus 4 to the 3, basically y is my a and 4 is my b, I'm going to say y plus 4 multiplied by y squared minus 4y plus 4 squared. And that's as far as I'm going to be able to factor it. In the second one, I've got 100x squared minus 9. Okay, so I've got a square, I've got two things subtracted. This is going to be a difference of two squares. So I just have to write down what are each of these things the square of. So 100 is the square of 10, and x squared is the square of x. And 9 is the square of 3. Okay. And then our pattern is a squared minus b squared is a plus b times a minus b. So a is 10x, b is 3. I'm going to factor it with 10x plus 3 times 10x minus 3. This next one has got four things right in a row. Okay, so I think in this class, if you see four things together, obviously you're looking for greatest common factor always. But if you see four things, it's kind of got to be group and factor, because that's the only factoring technique we have for string of four things in a polynomial. So I'm going to take the first two and I'm going to say what's common to both of these. Okay, I see a 4 and 2 powers of y, so I'm going to factor out a 4y squared. Oops. So 4y squared, and I'm left with, what do I multiply 4y squared by to get 8y to the 3? I think 2y and then a negative 1. And then from the second two, I've got this 50 and 20, so I can factor out a 25, and it's like, should I factor out negative 25 or should I factor out positive 25? I want to be left with a 2y minus 1, so I think I need to factor out negative 25. And I'll be left with 2y, because that will give me negative 50y, and minus 1, because negative 25 times negative 1 would be positive 25. And then from this expression, I can factor the 2y minus 1 out of both of these. And then I'll be left with the 4y squared and the negative 25. Oh, and look, this 4y squared minus 25, this is looking like a difference of two squares, so I can keep going. 4y squared is going to be the square of 2y. 25 is the square of 5. And so I'll have 2y plus 5, 2y minus 5, and that's as far as I'm going to be able to go. Alright, number 4, I'm seeing a greatest common factor here. I see 3 powers of y in both, because I got a y to the 5 and a y to the 3. And also 48 is divisible by 3, so I'm going to factor out 3y to the 3. And then I have to multiply 3y to the 3 by 2 more powers of y to get 3y to the 5. And a negative 16, because 16 times 3 is 48. And I'm going to continue to factor, because y squared minus 16 is a difference of two squares. And yeah, that's as far as I can take it. Right, now these next two are trinomials, and I would generally recommend that if you're seeing a trinomial, you're probably expecting it to eventually factor down like, old-fashioned Algebra 1 factoring like we did when we were doing quadratics in the last unit. So I'll start in here. I'm looking for a greatest common factor. I'm seeing 5 and 30 and 45, and I know all these numbers are divisible by 5, so I need to factor out a 5. And I should probably also factor out 2 powers of x, right? Yeah, because there's at least 2 x's in each of these expressions. So I'm going to factor out 5x squared, and I'd have to multiply that by x squared to get 5x to the 4. Positive 6x and positive 9. Okay. And so now I'm trying to factor this thing in the parentheses. And I'm thinking, what are 2 numbers that multiply to 9 and add to 6? And that would be 3 and 3. So I'm going to say this is 5x squared multiplied by x plus 3 multiplied by x plus 3. And, if you wanted to, you could say that's 5x squared times x plus 3 to the second power. This one, I'm also seeing a greatest common factor. I'm thinking we can factor out just an x. And then I'll be left with x squared, negative 2x, and negative 24. And then I'm thinking, okay, I can factor this. What are 2 numbers that multiply to negative 24 while adding to negative 2? Okay, so 24's got a lot of factors. It's got 24 and 1, 12 and 2. That's not going to be it. 8 and 3, 6 and 4. There we go. So 6 and 4 has a difference of 2. So if I make it negative 6 and positive 4, then they would multiply to negative 24 and add to negative 2. So I've got x times x minus 6 times x plus 4. And yep, that's as far as I can go. Okay, now I'm thinking again, greatest common factor, so I'm going to say I've got a 3, because 24 is divisible by 3, and 2 powers of n, so I'm going to factor out 3n squared. I'll be left with an 8 there, plus n to the 3. Okay, now this thing right here, this is a sum of 2 cubes, because 8 is 2 to the 3, and n to the 3 is n cubed. Okay, so I'm going to need to remember my sum and difference of cubes pattern, and since that one's so new to us, I'm just going to copy it in each time. Because this is one of those things that we just have to know in this class. And if you're, given something and you're just tasked with remembering it, the best way to remember it is to just use it a bunch of times and write it down and say it, in your own words. So if I've got the sum of 2 cubes, a to the 3 plus b to the 3, I start off with a skeleton, a and b and a squared, ab and b squared. And then it's the same sign, so plus, opposite sign, negative, and this one's always positive. Okay, I'm going to identify what's a and b. Now if you want to turn it around and make it n to the 3 plus 8 and factor it that way, you're going to get the exact same thing, because of kind of the symmetry of this formula here. If that makes you feel better, then you can do that. I'm just going to show you that it really doesn't matter. I'm going to have a being 2 and b being n. So 2 plus n multiplied by a squared would be 4 minus 2 times n plus n squared. And it wouldn't matter if I said n squared minus 2n plus 4 or n plus 2 instead of 2 plus n. We know these are the same thing. So that's how I'm going to factor that one. Oh, I'm going to need some more room for this one. Number 8 is 2x to the 3, so I've got 4 things. I'm expecting group and factor. Okay, so, and I kind of see that parallelism here, that ratio of 2 to 1 right here, negative 72 to negative 36. Okay, so I'm thinking this is looking ideal for group and factor. So what can I factor out of 2x to the 3 and x to the 2? I think 2 powers of x. And then I'm left with 2x plus 1. And then from negative 72x and negative 36, I think, because 36 times 2 is 72, I'm going to factor out the negative 36. I'll be left with a 2x to get negative 72x, and a plus 1 to get negative 36. And now I can factor out this 2x plus 1. Be left with an x squared minus 36, which is a difference of 2 squares, right? So I can factor that. That's going to be x plus 6 and x minus 6. And that's as far as I can go. Decompose it into linear factors. All right, now this one, Oh, yeah, this one's tricky. Okay, so 16 and 54, it's like, do these have any common factors? And so I guess, we're going to need to do a little bit of investigation to determine that. So 16, that's going to be 8 times 2. And because I can see how this one's going to go, I can tell you we're just not going to need to go any farther than that. And 54, but actually maybe I'll say x to the 5, and then I'll split the x to the 5 out into x to the 2 times x to the 3. To do this like I did in the lesson, where I was splitting everything out into its factors and identifying the common factors so I could get the greatest common factor, because this one's a little tricky. And then 54x squared. Well, 54, first thing I would think is 6 times 9 is 54, but I don't think that's going to be super useful, because I'm trying to get like even number powers, so I need 2's, or even numbers out of it, because I've got a 2 and an 8, and those are just all 2's. So I think I need to divide 54 in half, and that'll be 27 times 2. And 27, I know that's 3 times 3 times 3, and I won't be able to, get any common factors with the other thing. Okay, so and then x squared, I know I'm going to match that up over here. So I've got an x squared in common to both, and a 2. So that'll be my greatest common factor, it'll be 2x squared. So 2x squared. I'll be left with, okay, what do I multiply 2x squared by to get 16x to the 5? I gotta multiply the 2 by an 8, and the x squared by an x to the 3. Okay, minus 2 times what is 54? 2 times 27 is 54, and that's what I'll be left with. Okay. Also, I didn't even really need to think about that because I could have gotten 8x to the 3 from this and the 27 from that, okay, because of the factoring work I'd done earlier. This is going to be a difference of 2 cubes. Okay, so I'm going to copy in the pattern. Or actually, hold on. First, I didn't do this in the last one. I probably should have. I should have said, okay, so this is 2x squared. And 8x to the 3, that's something cubed, and 27 is also something cubed. So 8x to the 3 is going to be 2x taken to the third power, and 27 is 3 taken to the third power. Okay. Now for the pattern. Okay. It's a and b multiplied by a squared and ab and b squared, and then the first sign is the same, the second one's the opposite, and the third one is always positive. So in this case, I've still got the 2x squared on the outside, and multiplying that. Okay, I guess I don't really need that. A minus b, so 2x minus 3 multiplied by 2x squared. So if I square 2x, I'm going to get a 4 and an x squared. A times b is 2x times 3, so it'd be plus 6x. And plus b squared would be plus 3 squared is 9. And I think I told you about it in the lesson. May not have given you exactly a super robust reason why. I think I'll do that in the next unit. But when you factor sum and difference of cubes, this thing here is never factorable. There's never anything else you're going to be able to do with this. So you know that once you do sum and difference of cubes, that you're, at least with that second factor, you're going to be completely done. I suppose it would be possible that you could have like, I don't know, some sort of common factor in there. I'm not sure. I would not give you that type of problem though. Right, this next one, I feel like this has got to be a difference of 2 squares because I can't make it a difference of 2 cubes because it's the end of the 4. 625, that's, I know that's a power of 5. It must be 5 to the 4, but we can figure this out, right? So we can go over here and we can say 16 n to the 4. That's pretty clearly 4n squared. The 625, I think that's 125 times 5, and 125, oh yeah, and I know that 25 quarters is $6.25. I was just not thinking about it backwards. Okay, so I've got a difference of 2 squares here, and yeah, I'll be able to do this, and I think, we're going to have another difference of 2 squares, yeah. So here we are. I'm going to say that this is first thing plus second thing, first thing minus second thing. So 4n squared plus 25 multiplied by 4n squared minus 25. And if you're ever unsure, you could always just check by distributing using FOIL. Okay, yeah, that's going to work. And then this one right here, this is also a difference of two squares, so I'm going to factor it as well. So I got 4n squared plus 25 multiplied by 2n plus 5 multiplied by 2n minus 5. The last of these, just like here it is, factor it type problems. This is another run of 4 things, and so we're expecting group and factor because there's 4, and also I'm really expecting group and factor because I'm seeing this parallelism, 9 to negative 16, 9 to negative 16. So yeah, okay. I'm thinking 9 and 16, they don't have any common factors. Oh, but it's high powered. Okay, but I bet there's some sort of like cube thing going on here. So I think all I can factor out of the first two is going to be the 7 powers of x. Okay, x to the 7 multiplied by 9x squared minus 16. Oh, and that's a difference of 2 squares. Interesting. I think this one's going to have a lot of stuff going on here. And then the second one is going to be, it is 9x to the 6 minus 16x to the 4. I guess I'm just going to have to factor the 4 powers of x that are common to both. And I'm left with 9x squared minus 16. Yeah. Okay, then I'll factor 9x squared minus 16. And I'll be left with x to the 7 plus x to the 4. Alright, I'm going to need more room. Goodness, I did not leave that much. Okay. 9x squared minus 16, that's a difference of 2 squares. So that's going to be 3x plus 4 times 3x minus 4. I'm also going to factor out 4 powers of x from x to the 7 plus x to the 4. So I'll have an x to the 4 multiplied by x to the 3 and positive 1. That's a sum of 2 cubes. And that's kind of the thing that's newest to us, so I'm going to copy in the pattern. And if it's a to the 3 plus b to the 3, this will also be plus, the same, opposite, and always positive. So I'm going to copy in all these other factors, 3x plus 4, 3x minus 4, x to the 4, and then x to the 3 plus 1. So x is the a and 1 is the b. So x plus 1 multiplied by x squared minus 1x plus 1 squared. Okay, and that was a lot. Had a lot of factors, but that was a good problem. Alright, so number 12. This one looks like there's a number of ways we could do this. I think the most proper way to do this would be if we've got an area and we've got one side length, then we would use division to find the other. And so that's what I'm going to do, just kind of like my first instinct. Because if this is like with x plus 1 multiplied by w is going to equal a. So w is going to equal a divided by x plus 1. Okay, and they gave us an expression for a, that's 2x squared, 5x, and 3. Yeah, so I'm going to use synthetic division, right, because I'm dividing by something relatively simple like x plus a number or x minus a number. So I've got 2, 5, and 3, and I'm dividing in negative 1, so it's 2, negative 2, 3, negative 3, 0. So I'm left with 2x plus 3 and no remainder. So w is 2x plus 3. Also, you could have factored this thing, I think, pretty visually. You know, if you know x plus 1 is a factor and you're trying to get to 2x squared plus 5x plus 3, I mean, you pretty much have to have 2x to get the 2x squared, and you need a 3 to get that last term, and then you check and make sure it fits. That's another option you've got. Or you can factor this, you know, like as if you don't know what the factors are at all. And you can say, okay, what's two numbers that multiply to 6 and add to 5? And that's 2 and 3. So I'm going to say 2x squared plus 2x plus 3x plus 3. And then I'm going to do group and factor to just factor a, kind of the way we already knew how before this unit. And I would factor out a 2x and be left with an x plus 1. Factor out a 3 and be left with x plus 1. And then I see that I've got x plus 1 multiplied by 2x plus 3. Okay, so it's kind of like, you can figure this out a number of ways. However you want to do it, it's fine. Okay, so we're right back to just finding the factors, but that's all I was telling you about in this lesson was factoring, so I'm not surprised that there's a lot of factoring here. Okay, we're going to find the factors of x to the 4 minus 5x to the 2 plus 4. Okay, so this is one of those kind of like different ones that actually is like the ones you're already familiar with. Okay, so if we see that fourth power, second power, no power pattern, you just remember, okay, we're going to actually factor it in x squared. So it's going to be like x squared plus a number, x squared minus a number. But if you're having trouble seeing that, I always recommend, say, let t equal x squared. Okay. Then if t equals x squared, then t squared equals x to the 4, right? So I'm going to say that that x to the 4 is now a t squared. That negative 5x squared is up minus 5t plus 4. Okay. And that's something that we can factor. We know how to do this. We can think of two numbers that multiply to positive 4 and add to negative 5. I think that would be negative 4 and negative 1. And then we'll substitute back, right? T equals x squared. So that's x squared minus 4 times x squared minus 1. These are each a difference of two squares. And that's as far as we can go. Okay. I think this one's going to be the same way. It's not going to be fourth power, second power, no power, but it's like I've got twice as much power. And so I think it would factor in x to the 3. Okay, so I'm expecting like x to the 3 plus a number, x to the 3 minus a number. So, if you wanted to do it just like kind of all in one go, just kind of attack it and be like, what are two numbers that multiply to negative 8 and add to negative 7? That is going to be how it works. And you could always check your answer. I'm going to let t equal x to the 3. So that t squared equals x to the 6. And then I'll have t squared minus 7t minus 8 is my polynomial. And I can say that's equal to t minus 8, t plus 1. Okay, two numbers that multiply to negative 8 and add to negative 7. Okay, and then I can substitute back on t and say that's x to the 3 minus 8 multiplied by x to the 3 plus 1. Okay, I've got a sum and a difference of cubes, so I guess I need to copy in both of those patterns. Alright, so for the first one, the difference of two cubes, I'm going to make that minus, and then this will be the same, the opposite, and this one was always positive. Okay, for a to the 3 plus b to the 3, it's going to be the same, opposite, and always positive. So that x to the 3 minus 8 is going to be x minus 2, because x to the 3 is x cubed and 8 is 2 cubed, times x squared plus 2x plus 2 squared. And then x to the 3 plus 1 will be x plus 1 multiplied by x squared minus 1x plus 1 squared. That's a lot of factors. And again, like I told you earlier, this thing and this thing will never be further factorable. Okay. So then the last one we've got here is find the factors of x to the 4 minus x to the 3 minus x plus 1. And this has got to be group and factor, right? Because it's 4 in a row. So let's go and just do what's common to x to the 4 minus x to the 3. That would be x to the 3 multiplied by x and a minus 1. And then nothing really common to negative x plus 1, but I want to make it x minus 1, so I need to factor out that negative 1. I'll be left with an x and a minus 1. Okay. I can do group and factor, or factor out the binomial, x minus 1, and we'll be left with x to the 3 and a negative 1. Okay, that's a difference of two cubes, but I've already got it copied in and I've done it for you a bunch of times, so I'm going to just use that, and I'd say x minus 1, x to the 3 minus 1 would be here x minus 1 times x squared plus 1x plus 1 squared. Okay, and if we just had to, we could combine the two copies of x minus 1 and say that's x minus 1 to the second power times x squared plus x plus 1. Alright, that's all the problems for this homework. Thanks for watching, hope this helped.